Hey everyone, welcome to Physics 106 tutorials. Today we're going to talk a little bit about a principle known as Huygens Principle, or Huygens Principle. I'm not sure how to say it or barely even spell it, but I can promise that the principle is a lot easier to grasp than the spelling of this man's name. So, Huygens Principle has to do a lot with waves. So, a couple centuries ago, people were noticing these waves, and I think waves are pretty familiar to us. There are plenty of things in our universe that travel as waves. For example, we know that sound travels through air in waves. We also know that light and other forms of electromagnetic radiation exhibit wave-like properties. And my personal favorite, if you've ever been to the beach, you know that water also can travel as waves. There was a question that people had developed as they had observed these wave phenomena over the years. What makes it possible for waves to propagate, meaning they continue to repeat this same pattern? There was also questions regarding sound waves. For example, you could have sound waves. This is a vertical view. You could have sound waves that come this way and that attempt to pass through a doorway here. But rather than continuing in the same pattern that they had before once they passed through the doorway, the waves were found to diffract and emit this pattern. And people had absolutely no idea how this was taking place. So in the 17th century, there was a Dutch scientist named Christian Huygens who postulated a theory about the propagation of waves, transverse waves specifically. So you saw above that we can draw a vertical view of what a wave might look like. Each of these lines represent the wave fronts, or the crests that we were seeing here. So Huygens postulated that every wavefront is made up of these little wavelets here. And Huygens said that each of these little wavelets emits their own circular wave. When these circular waves are being emitted at the wavefront, a new wavefront is able to form tangent to each of these wavelets. Each corresponding wavefront would also be made up of these wavelets and emit their own circular waves. The next wavefront would then be made tangent to those wavelets. So this theory might seem a little bit interesting or confusing at first, but it actually helped to explain a lot of the principles that people were seeing. So if we're going back to the sound example we were mentioning before, when we have sound waves that are coming this way, and when you have your wall right here, and your doorway opening, as the waves approached here, again, we'll have our wavelets drawn in here with their corresponding circular waves. If you notice the next wavefront, cannot totally pass through this opening. And so the only one that passes through is this one here. Then you have another wavelet here that's tangent to that wavelet, forms its own circular wave, and then tangent to that is the new wavefront. But you notice that this wavelet is emitting more than just the straight lines that we were seeing over on this side over here, because it's not experiencing any interference from as many nearby wavelets. It's able to spread its circular wave, out. And so the next wavefront would look like this, each corresponding one made up of wavelets with their own circular waves, and the next wavefront is here. And that perfectly explained why the sound was diffracting when it passed through these openings. For example, like someone could be over here, I don't know, playing a vuvuzela or something. I know this is a terrible drawing. And it would pass through the door. And initially, old physics would say that you would only be able to hear this sound if you were standing right in line with the doorway. However, Huygens Principle teaches us that you don't have to be standing over there. In fact, you could be standing right here in the corner of the room and still pick up the sound because the waves are diffracting, thanks to Huygens Principle. So it's kind of an interesting principle, but it actually explains a lot of how waves are propagating in our universe. One thing to note is also that the diffraction of the waves, or the bending of the waves as they pass through the aperture, depends on the ratio of the wavelength to the size of the aperture. If we see in this image here, when light passes through, say, an open doorway, light's wavelength is so small compared to the opening of the doorway that we won't see any visible diffraction. We'll just see like a ray of light that just passes straight through. However, sound has a much longer wavelength than light. So if we'll notice in the second picture, since the wavelength of sound is closer to the size of the opening, then we're going to see some diffraction where you can see a person in the corner of the room still hearing the sound that is passing through the doorway, even if they're not standing directly in front of the opening. So remember, just to review, each wave, remember that these are the crests that are made up of this wave here. Each wavefront is made up of wavelets, which are abstractly illustrated by these dots here, and each one is emitting its own circular wave. The wave propagates because a new wavefront is formed tangent to all of those circular waves. And then the process repeats itself and the wave continues. So, thanks everyone for listening to my tutorial on Huygens Principle. Really appreciate it. I hope this helps you in your physics studies.